Dear students, welcome to my sixth video for engineering thermodynamics course, and the title which we are going to cover is zeroth law of thermodynamics. And as a continuation of the past videos, I want to shoot some questions to you people, and you just note it down and you can solve later, and we will discuss in the next forthcoming videos, and that you try to distinguish between mechanical and thermal irreversibility, which I have taken and given some important tips about this, and internal and external irreversibility. Next, about the following aspects render how a process as irreversible, how these factors making the process to irreversible one: frictional resistance, free expansion, and stirring of liquid by means of a paddle wheel. Okay, so try to explore this. Next we will move to working substance. Okay, already in the first initial videos I told about what is matter, what is substance, what is element, compounds, atoms, molecules, everything. Okay, and the differentiation between homogeneous and heterogeneous, and heterogeneous compositions existing in single phase and multi-phase, pure substances, everything. Okay, now here what we mean in working substance is the fluid, or either it may be solid, liquid, or gaseous. It may be existing in any one of the state employed in thermodynamic devices, which are utilized in thermodynamic devices to serve as a medium for transformation from one form of energy between the system and the surrounding. Okay, so here I told about, so many times I talked about, whenever I am explaining any one of the system, I used to tell you take 1 kg of ice, you take 1 kg of air, or water is converted to steam, vapor, like that I had told about you. Okay, so what is the substance which we are taking, and by which only that energy conversion, to whom you will give the heat, from which point you will extract the heat, that is called the working substance. You will extract the heat from burning the coal, and you will transfer that heat into water, and that would be converted to water vapor, and finally you will extract the work from the turbine. Okay, if the water vapor hits the blades of the turbine, then only the blades of the turbine will start to rotate, by which it could be linked with the generator or something, and you can make the power. Like that, some sort of fluid should be employed in converting or transforming the energy from one place to another place, which is serving, is called working substance. Okay, so in refrigeration, you can have refrigerants, which could be used in air conditioner and ice making planes, water vapor in steam power plants, combustion products of hydrocarbons used in thermal power plant, and petrol and diesel engines. These are all some of the examples, few examples for working substances. Okay, and how we have to select this working substance is, it should be easily available and transported from one place to another place through the pipes. Then it would be convenient for us to conduct that particular process and get or extract the work from that point. Okay, let us revise the basic terms of mass in kg, force in newton, weight in Newton, and specific weight Newton per meter, density is kilogram per meter cube, specific volume is meter cube per kilogram, and specific gravity has no unit. And you try to know the definitions which could be applied in all the problems you are going to solving in this course. Forms of energy. Okay, so from the first topic onwards, we have been telling repeatedly about energy, heat energy, work energy, like that, right? Okay, so energy, now we are entering into the energy, forms of energy conversion. Okay, so energy is nothing but you would have come across this word in your home also. Your parent would have told energy, what is your energy, how you are working, how much you are efficient, and how much you are capable of converting the things to useful one. Everything is depends upon the energy level possessed by you. Okay, so this energy here also, the energy or the capacity of any substance or working substance to do the work or to produce a change from the existing condition. Okay, it has to do something efficiently, effectively. Okay, forms of energy is one type of energy could be stored in the system. It can be stored, that is if you take our home. Okay, so we are all the constant uh, members present or available, or which can be stay in our home. Okay, we are all stored energy or stored person or stay person in our home. Okay, energy in transition is nothing but who are all coming or entering into our home as a guest, as a guest. Okay, so here stored energy is permanent people staying in our home, and energy in transit or the energies or the guest um, which entering and leaving our home. Okay, so stored energies or internal energy. First class of stored energy is internal energy. It is the energy of the molecules. And when this internal energy can be explicit, or it can be expressed or represented, or it can show its capability, is when you are giving the external heat given to the system. Means then the internal energy of the molecules would be increasing. A very simple example: when you are boiling the water, the water gets heated, and initially its temperature was increased, and after a particular point of time it would starts to boil, and moving from one place to another place it will get bubbles, and after some time it will starts to evaporate, right? Okay, so its energy is increased, keep on increasing by the continuous supply of heat. Okay, so here heat energy is utilized for increasing the individual atoms or molecules internal energy means the possessed energy of the molecules is coming out by the application of temperature or heat. Okay, energy stored in the system could not be fully converted to work. That is this all the heat which is given to the internal energy, or the increase in internal energy could not be converted to useful work. It is not possible. And change in internal energy of the system can be written as mass of the substance into heat capacity at constant volume CV into difference of temperature before and after the heat supply. Okay, uh, kinetic energy, potential energy are the basic energies which you have come across in your schoolings. Kinetic energy is half mc squared minus c1 squared. C tends for here velocity after and before the movement. Okay, that is here the kinetic energy, the molecules are being transferred from one place to another place. And next, if we come to potential energy, means you know very well, when during the stationary point of or its position or elevated position, how much energy possessed by the substance can be named as potential energy, which is the mg. Height is how much amount of elevation was taken place by that energy possessed by the system. Okay, energy in transit. What about the guest? Is very important. Guests are more important than the members who are present in our home, right? So here all the other three, internal energy, kinetic energy, potential energy, are stored energy which can be stored inside the system. Okay, energy in transit means energy which crosses the boundary of the system. Guests who are entering and leaving out of our home, okay, they'll be doing some important work, or the stay has some reasons behind their arrivals, right? Okay, like that here, heat and work are very important energy transit energies who are coming as a guest to the system, doing their work during the process, and if they once they left or they entered into the system, their importance or identity will be lost. Identity will be lost. Heat and work are manifested or expressed or they are explicited only they were crossing the boundaries. And this is most important. Please keep it in your mind. Other forms of energy are flow energy. Flow energy means the energy required to make the flow of the substance from one place to another place out of the device, which is called P2 minus P1 V1. And enthalpy is another one more important energy possessed by the system, which is equal to this is denoted as H, capital H for extensive property, and small h denoted by intensive enthalpy. Here it can be called as the summation of internal energy plus product of PV, which is flow energy. So if the fluid is possessing both internal energy and the flow energy, because of the supply of the temperature, the internal energy is increased and the fluid or the working substance is moving from one place to another place because of the increase in internal energy, then the summation can be called as enthalpy. Okay, which can be directly written as mcp T2 minus T1. Here already we have our U equal to internal energy, change in internal energy is equal to mcv dt, but enthalpy is mcp dt. Okay, dt means change in temperature. And here also you have Q, heat supplied, is equal to change in this internal energy and flow energy, that can be separately written as U2 plus P2 V2 minus U1 plus P1 V1. This can be written as H2 and this can be written as H1. So H2 minus H1, heat supplied. Okay, heat supplied could be found out by change in enthalpy also. Enthalpy is it is applicable for open system, and internal energy term is applicable for closed system, because closed system does not have this flow work PV. Closed system will not move from one place to another place. There is no mass transfer and there would not be any flow takes place in the closed system. So only you will be accompanied in closed system. Once if U is added with flow energy, then we can call it as enthalpy utilized for open system. Okay, so here another one more very important proof is this energy is a property of the system which can be stored inside the system, except that is we are not talking about heat and work. Explicitly they are boundary crossing phenomena. Okay, they are something different which they are doing their purpose. Okay, after the purpose they will leave the system. Okay, during the process only we can they can get their identity. Okay, so here is the proof for derivation for showing that energy is a property of the system. Okay, so thanks for patient listening. Let me continue in the next video, and please revise the topics which we have covered. Okay.